Hi everybody, this is James with geothermalhelp.com. I'm here to talk today about a no-brainer situation that people can identify out there that basically I believe it's a situation that represents where a ground source heat pump system would be of the very highest value to whomever it is that's got a project with these variables as such. And they are being installed all the time well, I should say that these projects are moving forward a lot of times without ground source heat pumps, again, always due to the lack of knowledge. So for a second here, let's just go over what these points might be that go to make up a no-brainer situation. And there's going to be a lot of variables out there. I'm picking on one type of situation here in particular, and in other videos and in other articles we will identify all the other variables that exist that may also lead somebody to conclude that it is also a no-brainer situation and the ground source heat pump should be the right thing to be put in there. And the fact, by no-brainer I mean this: the people who own these properties or who are building these homes and that are in charge of these projects, that are paying the energy costs of them, are going to be losing money from the very get-go if they do not go with the ground source heat pump. If they choose the conventional alternative, they're going to lose money from day one going forward. And I'm going to show why. The first variable on this particular example is the system could be an open source system. And that means it can have a well or some other source of water that's plentiful, available to give it 2 to 3 gallons per minute per ton of capacity for the system. 1 ton is 12,000 BTUs per hour delivered. And open source systems, for example, let's say you have a house in the country and it's new construction and they're going to supply the house its domestic water from a well. That very same well, if it has enough capacity to feed the heat pump in addition to feed the structure, becomes part of the geothermal system and is therefore part of that 30% federal tax credit. And that isn't even part of the gray area of the federal tax credit, and I have videos and articles about where there is gray area on that. But that would be one that you need an earth loop for the geothermal system. The very well that happens to provide the home its domestic drinking water and all the domestic uses happens to also feed the ground source heat pump. So therefore the cost of drilling that well, the cost of developing it, you get a 30% tax credit on that because it's now part of something more than just a domestic well. So there's a great opportunity there, and it's, you know, that's your feed to the heat pump. Now, the only other thing that's needed in an open source system in order to complete the earth loop is a discharge. Now, you may need a reinjection well, depending on what state you're in, what the laws are in that area. In Montana, as long as you're using less than 35 gallons per minute that are allowed, you could put it into a French drain. You could get rid of it really anyway, as long as you're using less than the 35 gallons per minute, and you're doing it in a way to where you can consistently ensure that the discharge water is going away. Now, it's considered no consumptive use of the water because, remember, we're not harming the water any. When the water runs through the heat pump, it's just simply becoming a little hotter or a little colder depending on what mode the heat pump is in. So an open source system is the very least expensive type of earth loop to install, and in many cases, as I mentioned with the domestic water well, it may have an advantage that even goes beyond it being inexpensive. Now, if it does require a reinjection well, then you have to figure that cost in, but again, that well is also part of the 30% discount. I don't mean discount, 30% federal tax credit, and then there may be state credits that apply. So the first no-brainer is it an open source? That's the least expensive type of earth loop. Okay. Number 2, is the project heating with propane if they don't use this? Are they going to have a propane-fueled furnace or boiler? Many times, if they're in the country and they're heating with a well, or they have a well feeding the home, that is the case. Not always. Depends on if it's an established subdivision or if it's out somewhere in the middle of nowhere. But in any case, whatever it is, if they're using propane, propane is more expensive right now than natural gas, pretty significantly. Right now it would take, for every 100,000 BTUs delivered, a 90% efficient propane boiler or furnace would be able to deliver that 100,000 BTUs at a cost of somewhere like $3.02 out here in Montana, and that's based on about a $2.50 per gallon of propane cost. But remember, we don't get all of that heat energy. Some of it goes up the flue, and there's only about 92,000 BTUs per gallon of propane. In any case, propane's an expensive fuel, so that's your number 2 checkpoint. If you're on propane, it makes it all that much more likely that you're going to have a no-brainer situation. Third point would be low temp distribution compatible. Now that means if we're talking about a retrofit situation, how is the heat being delivered into the home? Is it forced air? Is it radiant? Is it hot water baseboard? You know, what is it? And those all have their own different levels of compatibility with low temp, but basically ground source heat pumps make a maximum of 120 degrees, and that is more compatible with some situations than others. For example, a hot water baseboard system is not very compatible because it's got such small square footage areas of heat delivery to the space, and therefore when you've got small areas of delivery, you need to ramp the temp up a lot higher in order to deliver those BTUs into the space as fast as the room is losing them. A radiant floor, for example, that's going to be either a slab on grade or a thin slab application that's above the subfloor would be very compatible with low temperature because you're using the entire floor surface as a distribution panel, and therefore all that floor surface doesn't require nearly the high temp as it would with a smaller distribution system. Forced air systems are often compatible with it, but we need to look at the duct sizing and determine whether or not the CFM requirement that we're going to push through those ductworks might create noise if we up that flow with the ground source heat pump system. In any case, it's a calculation that would need to be made, but is the low temp distribution compatible if it's an existing structure? And if not, it could easily be built to be compatible if it's new construction. And number 4, alt energy loans. Many states and many other entities have alternative energy loan programs available for the installation of these systems that is at reduced interest rates, and it makes the money available for doing it all that much more accessible and all that cheaper to borrow. And what that ends up with a situation you can see from the economics video or on the economics articles, when we look at the time value of money and we look at the time value of energy savings, the relationship of those two things will determine whether or not you're going to have a no-brainer situation or not. If your energy savings of your ground source heat pump is going to pay for the principal and interest of the money that it takes to borrow it, to put that system in, if it will pay for that and put money in your pocket, then the term payback that everyone likes to use with these systems becomes a moot point. And therefore, it's simply not something we need to worry about. That's the basic situation of this no-brainer situation. Stick with us. We'll come up with more in the future. Thanks for watching.